Hi, so welcome to today's video lesson, and in today's video lesson we're going to be talking about the concept of work. So what exactly is work? I know many of us start think about work, just work from go to work, you go to the office, of course you'd carry load and all of that. So but in physics it's quite different. The concept of work is quite different. So what is work? Work is actually said to be done when a force moves a load or a body, and a force moves a load or a body through a certain distance and that work is actually equal to the product of the force multiplied by the distance at which the force actually um, dragged that load or changed the position of the load. Okay, and the force is actually measured in newtons, the distance is measured in meters. So the unit has to be Newton meter, but standardly work is measured in joules. So we have looked at that before. So that work is measured in joules, but basically work is actually defined as a product of the force and the distance. Okay, so the force and the distance. So you see, I just want to explain one thing before I move on to explaining another concept behind work. 1 joule, what does 1 joule means? Because you could come across this in an objective question. What does 1 joule means? 1 joule. Remember, what work done is measured in joules. So 1 joule is going to mean that 1 Newton multiplied by 1 meters, and that gives us 1 joule. So basically what we are saying is that 1 joule means that when a force of 1 Newton is applied to move an object of a distance of 1 meters. So that's when we say a work of 1 joule has been done. So when newtons of force is used to to change the position of a body by 1 meters, then the work done there is 1 joules. All right. So I also want to bring your attention to what about in a case. Now, if you notice that the diagram I drew earlier, I actually drew it that the force is in the same direction as the plane. So this is the force, is in the same direction as the plane. But what about in the case where you have a block in like this, let's say a block of wood that has a mass m, then you have to move it through a distance, let's say this is d, from here to here. Now you apply the force at an angle, not straight like this, but at an angle, let's say like this, f. So that means it creates an angle with the horizontal. I'm going to call that theta. Okay, so how do we calculate for the force? How do we calculate for the work done, rather? How do we calculate for the work done? Now, I want to bring out this thing here. I'm bringing it out here. So that means that's going to look like a triangle. Let me draw that again. It's going to look like a triangle. Right? Good. And this is theta. This is f. Now, what I really want to do now is to find the f component of this. This is f sub x. That means there's a horizontal component to this f. So let's call this f. So, and this is going to be our opposite form and knowledge of trigonometry. Opposite, this is going to be our adjacent, and this is going to be our hypotenuse. So using the SOHCAHTOA that we understand, SOHCAHTOA, then where we are in need of just adjacent and hypotenuse. Okay, good. Adjacent and hypotenuse, and that gives us cos. Okay, so that's cos theta equals adjacent, that's f sub x divided by f. And what's going to be f sub x? So f sub x has to be cross multiply. I have f sub x equals to f cos theta. So that means I'm going to replace this. So remember, the f of f sub x now becomes f cos theta. Now I'm going to take you back to this. So now this is f of x, f sub x, right? We've resolved that. And remember that the formula for work done is actually f in that direction, and in this case I'm going to make it f sub x multiplied by d. Now I have f equals to what? What's f sub x? This is it, f cos theta. And so I have f cos theta multiplied by d. So this is the formula when the force is actually acting at an angle to the horizontal. All right, so